Let's see how we do this now in our hapi application. That is, do it inside donation web. How do we implement the JSON web token structure? So as with any new features in hapi, the first thing we'd be looking for would be, is there a module to support it? Does the framework support it inherently, or is there a plugin or library that's compatible with hapi that can implement what we want? And there are a number of options, so we'll be able to pick one of those. Need to look at encoding and decoding tokens because that's something we'll have to do in our application, and then authenticating our routes. We'll also integrate some of the new features into our tests. So before we start going back to Aurelia, we would need to verify that what we just implemented works. Easier to test that separately using the test framework we've been already using, the Mocha tests, rather than going straight to Aurelia without having proven that what we've done works. So here is the library. We'll use the first of two, JSON web token. It's a straightforward enough implementation of the JWT standard. General purpose library we'll install and save. Here is another library. This time it's a library that is a plugin for hapi itself. This will allow us to incorporate JWT guarding, if you like, into each of our routes. So we install that as well, in addition to the previous one. Now the general purpose library's got a variety of methods on it. We're only going to be using one or two. Effectively, it gives us a way of signing and decoding the tokens, so generating them and maybe reading them back from strings. Lots of options and variations in the API itself. We needn't get into it in too much detail. We want just basic usage. First thing we do is we write a new general purpose function, a utility function for generating the tokens. And this is it here. It uses the JSON web token module we've just installed, and the job of this function that we write is to create a new token. And notice what we're using here when creating the token. This is our payload. We discussed payloads in the previous section. This is the information that's going to go into the token that we may be reading back later. So notice we're storing the token to contain two fields, and the fields are the user ID and the user email. So when we're creating a token, we're creating it for a given user, and we're putting the user's ID and email into the token. The options are just standard, indicating how long we want it to expire. So it's going to last an hour, and the encoding algorithm. Finally, we sign the token, and having decided what we want in it, then we're going to create a new token here, and when we call JWT sign, we get the new token, and it's going to be encoded using the secret key. Well, not particularly secret, but you get the idea. We could be generating our own UUID for our application here and using it instead of that. Okay, so that's a general purpose function to create a token, which we bring into our hapi application. Not Aurelia, it's our donation web application. And here is the obverse of that, decode a token. If we have a token, can we read it? So this function is the opposite of the previous one. You supply a token as a parameter. We decode the token here, and then we extract the information we want, which is the user ID and email, which we've encoded, and that's passed back as the value of the function. So if we use this function then whenever we have received a token from somewhere, presumably from a request, and we want to see what's in it. Actually, what we're trying to see is this a valid user in our system. We've developed now a new route. This is only for the API clients, and we will rework the donation client Aurelia app to use this route. It's a new endpoint, API user authenticate, and it will assume you supply a username and password. We'll check to see is that a valid username and password, and if it is, generate a token. And you can see there highlighted where the token is created. Utils.create token using the user we've just recovered from the database. We reply with success true and token. So that's the object that goes back to the client if it was a valid user. So it's relatively straightforward, really. And just notice that if the user's email and password didn't match up, we're replying with success false and a message. The token then that we're generating is going back here as part of an object returned on a successful authentication. Let's remind ourselves about how authentication works in Hapi already. We've already implemented this here. That is, we had an authentication strategy, we call it standard, which was for securing the routes via cookies. So our standard server rendered routes were all guarded by this strategy. We had time to live there, and be secure as false for debug purposes. And you might remember that we set the strategy standard as default for our entire application. So when we put this into our startup, we were saying all routes are now guarded by the standard strategy, so auth default. But of course, that won't quite work because users need to be able to log in and sign up. So we were turning off security for sign up and for login, and maybe for the welcome page as well. So these routes would work as normal, but all other routes would fail if the strategy's requirements weren't satisfied, which was effectively that the cookie had been set up and was a valid user. Here is a new additional strategy then that we include in our server application. We're calling it JWT. Notice that the key is in here for creating web tokens. The algorithm is specified, and a new function called validate func has got to be implemented, utils.validate. And effectively what this strategy will do is, if this strategy is enforced on any route, then that function there, utils.validate, will be called. It will attempt to decode the token, and if it finds a valid username and password, the route can proceed. If the token is not valid, then the route will fail with an authentication error. This is the validate function here. All it's doing really is looking up the user in the database. So the token is decoded at this point, and we're checking to see if the ID maps to a user. Now, we're not doing anything with the user. We're not passing it back in any sense. We're just generating true-false values. Now, we could do more here. We could be also looking at email and see does the email and the ID match. So we could be doing a bit more checking here than what we're doing currently. All we're doing really is just checking to see that a valid token, and does the token contain a valid ID. If it is, then our happy routing mechanism will keep processing the API call. If it's not valid, it'll terminate. So we incorporate then this new strategy into our app. We'll go through this in the lab. And then any of the API calls that we want to secure, we just include strategy JWT as shown here. So we're not having to worry ourselves in every given API call. We're just turning it on, and if it's turned on, then the handler can remain as was. So there's no real change here. They just proceed as they always did, but they will be not even invoked if there isn't a valid token provided with the request. Now, to test this out, we go back to our Mocha unit tests. remember these from some time ago. We introduce a new login method in our donation service, and when we log in, we're checking to see if we can recover the candidates. If we're not logged in, we should get nothing. If we are logged in, we should get candidates, and if we log out again the route will be disabled. So this is a simple test as we can write, a sanity test if you like, to see if the routes are properly guarded. This is the new method in the donation service test class, log in, log out. And we are calling set auth and clear auth here in this login, log out. And we'll look at those in a moment. These are going to implement the login and log out mechanisms and ensure that the token is properly attached to subsequent requests. So this is a little bit involved here. Let's look at it. Here's the set auth. So this will be called when we're trying to effectively log in. So we're now, remember, inside the test client, seeing if this mechanism works. So the first thing we are doing is we are issuing a request to the authentication route and providing the user details, the user we wish to log in as, username and password. That request is synchronous, remember, because we're in the test. So if it works, we check to see if we got a return. 201 means success. And in here, we are recovering the return value, the payload that came back from the authentication route. We're looking into that route, that payload, sorry, to see if we got success. That is, if it turned out to be true. And if it's true, then we are able to store the token that we just received inside an auth header in our library. Remember, this here is going to be the token that we got back from the authentication route. That's being stored in auth header, which is here. And all subsequent attempts to access the API in our little test class here will check that auth header and include it in the request. When we want to clear the auth, when we want to log out, we just set that auth header to null. Here then is the revised implementation of get, post, and delete. And you can see what's happening here. Whenever we do a request, if it's a get request or a post request, we are always including the header here. If we have logged in, this will contain the token. And the token will be checked on donation web server side. Token is valid. We'll keep going. If it's not, then we'll be ejected. So this token is now being passed in all instances. So the token is being passed here and here and here. That is, every attempt to make a request through this class, either via get or post or delete, all of them will include the token, which will have been retrieved here when we attempt a set auth and a clear auth. So that's the pieces then of the puzzle. If you do this lab, this is the lab which is focused exclusively on donation web, and we run the tests, then we'll have verified that our APIs are secured with JWT tokens. Our remaining task then will be to implement JWT strategies in the Aurelia client so the client can log in securely. And we'll deal with that in the next lab.